All right, so this section is higher order polynomial functions, and we're grouping this together with Chapter 4 because we're still dealing with models. Now this section here is obviously, again, called higher order polynomial functions, and basically what that means is we're looking at things that are essentially powers 3 and higher. Now we're going to mostly concentrate on 3 and 4, and for the most part I think that's what you would see on the exam as well. So the deal is that when you look at that highest exponent, which is called your degree, based off that degree, you have a distinctive shape and characteristics for your graph. Now, first thing here is a turning point. Now, a turning point is where the graph changes from increasing to decreasing or from decreasing to increasing. Essentially, this is a local maximum or minimum. It's just a way to kind of group them together. You don't necessarily know how many of each one you're going to have, but together, cumulative, you can call them turning points and know total that you're going to have 3. But maybe it's 2 maximums, 1 minimum. Maybe it's 1 minimum, 2 maximums. Now, your book refers to maximums as humps and to minimums as valleys. I prefer to say peaks and valleys, but they're the same thing as minimums and maximums. Then you also have something called a point of inflection. Now, we're not going to talk too much about that, but that's going to occur between your extreme points. In this course, we can only estimate those. It takes more calculus than what we've done in here. But essentially, if I have a graph that, say, looks something like this, your inflection point would be about right there. So it's going to be where the graph changes from being a U-shape to an upside-down U-shape or vice versa. Your book calls it cupped. This one's cupped down and this is cupped up. But actually the proper name is concave up and concave down. So this area is concave up, this area is concave down. In between is your inflection point. So like I said, we're just going to kind of estimate that whenever it asks for it. Now, something that you know from, again, looking at that highest exponent at that degree, if you have degree n, then you're going to have at most n x-intercepts, which is the same thing as roots and solutions, zeros, that kind of thing. You're going to have at most n minus 1 turning points, which are those peaks and valleys, and you're going to have at most n minus 2 points of inflection. Now, I know that seems silly to say at most, and we'll talk about why that is in a little bit, but that is going to help you too, even with the graphing calculator. If you're not having to graph something by hand, it's still going to be helpful to know this information because it's going to help you know if you're looking at a complete picture in your graph or not. So, first off, we have a linear function, degree 1. That's just your line. So y equals ax plus b. This graph has no turning points, also no points of inflection because nothing's curved. And it has at most 1 x-intercept. And actually, this one, well, it's at most 1 x-intercept because if you have an x equals line, that one would not have any x-intercepts. But for the most part, a linear graph, degree 1, you're going to have exactly 1 x-intercept. Next for quadratic, ax squared plus bx plus c. This one's going to have at most 2 x-intercepts. Now, the one in the picture there just has 1. And then you are going to have exactly 1 turning point. Now for your cubic, degree 3, this one's going to have at most 3 x-intercepts and at most 2 turning points. This one would also, FYI, have 1 point of inflection. Now the whole thing about at most on this, so your general parent function for the cubic does this. So this is just x to the third, say ax to the third. So in that case, you only have 1 x-intercept and you actually have no turning points because your graph's increasing the entire time. So that's part of that whole at most thing. It depends on what the equation looks like. Okay, next we have quartic. In general, quartic graph looks like a W shape or an M shape if it's upside down. But you do have some quartic functions that look like a parabola. So again, it just depends on the equation there. So at most 4 x-intercepts, at most 3 turning points, and this one would have 2 inflection points at most. And then quintic has 5 x-intercepts, at most 4 turning points, and then again you would have at most 3 inflection points. And you can see an example of that graph as well. Now the end behavior is also very important. Again, helps you know that you've graphed something correctly. This has to do with values of the function as x approaches or gets closer to infinity or negative infinity. The degree and the leading coefficient of your polynomial function determine its end behavior. Both are helpful to know when you're graphing a polynomial function. So in all of our equations up here, our leading coefficients are a. And they're all in order, okay? So that is the first thing you want to look at. Make sure that your equations are in order. So if your n, your degree, is even and your a value is greater than 0, which means positive, your graph's going to look something like the one on the left. If it's negative, it'll look something like the one on the right. Essentially, if it's even, both ends go up. When it's positive, both ends go down when it's negative. The squiggly line, that's just because I don't know what it's doing in the middle. To give you an example up here on my quartic, it's doing a kind of little wiggle there in the middle. But that's the same general idea as this graph right here. That graph just isn't doing a wiggle at all. Okay. On the flip side there, if your n value is odd and your a is positive, the graph is going to end going up. If it's negative, the graph is going to end going down. So both of our odd graphs up there, the x to the third and the x to the fifth, those are all positive graphs because they all end going up. Okay, so just practicing this here a little bit. For the first one here, we're going to say what is the degree, that's even or odd. We don't know the number, but we can take a guess. The end behavior, the x-intercepts, how many do you have, and then how many turning points would you have? Okay, again, at most. Or no, I'm sorry, looking at the picture, because we do have a picture here. So the first one there, the degree, this one, the ends are doing something different. So this would be odd. The end behavior is going to be negative because the graph ends going down. X-intercepts, I have 1, 2, 3. And turning points, I have 1 minimum and 1 maximum, so 2. Okay, next one. This one is even because both ends go up. So that means it's positive because both ends go up. X-intercepts, 1, 2, 3, 4. And turning points, 1, 2, 3. Next, we have another odd graph because the ends do different things. This one ends going up, so this is positive. The x-intercepts, that's going to be 1, 2, 3, 4, 5. And turning points 1, 2, 3, 4. Okay, well the last one, the degree is even because both ends do the same thing. They both go down, so this is going to be negative. X-intercepts, I have 2. And then turning points, I have 1, 2, 3. So that's a little bit different than all the rest of them. So this is one of those ones where, again, it's at most. This graph could be at the smallest x to the 4th power. Because remember on the front, it says that you have at most 4 x-intercepts. Well, this one only has 2. You have at most 3 turning points. This one has 3. It couldn't be something squared. Obviously, it doesn't even look like that. But sometimes they could ask you to take a guess at what type of equation you got going on. And so you want to evaluate all the pieces of information. So in this case, it could be higher than x to the 4th, but it could definitely not be less than x to the 4th. All right, now more of what you're going to have to be doing, I'm assuming, is here's an equation and know some stuff about it. So the first one here, your leading term would be x to the 3rd. Oh, and I didn't even notice here that it says sine. We'll do that in the next part. Sine and degree, this is positive, and your degree would be odd. So the end behavior, the graph is going to end going up. So you can do this kind of thing, just kind of a general graph. I don't know what the graph's doing in the middle, but I know what the ends are doing. Or you can write it in words. The left goes down, but the right goes up. Max number of x-intercepts, that would be 3. That's your degree. And max number of turning points, that would be 2. That's 1 less than your degree. Okay, next, negative 9, x to the 6th power. Sine and degree, that's going to be a negative, even. Negative, even. In behavior, both ends are going to go down. So you can write that in words if you would like, but that little picture over there is fine with me. Max number of x-intercepts, that's going to be 6. Max number of turning points, that's going to be 5. Now, we are going to talk about this a little bit, but I did want to kind of put it in writing here too. So the graphs there at the right, whenever the graph touches, or our book calls bounces, on the x-axis, that counts as a double zero. Now, it's possible it could be a quadruple zero or a sixth zero or a 10th zero. Essentially, it's an even number zero. And what that means is that if you factor it, you're going to have that as a factor more than once. Now, when you list your zeros, you're not going to list that as a zero more than once, but it does cause the graph to do that. You can have ones that are cubic, and essentially what happens on that, if the graph kind of bends as it goes through, rather than going straight through, they call that an odd multiplicity zero. Again, we're not going to really look at that one here. Okay. Now, we got a couple equations here to graph. So the first one here is factored, which is nice because it makes it really easy to find my zeros. So my zeros, I'm going to set all my factors equal to 0. Now, I've got one of them twice, so I don't need to do that twice. But what that's going to mean here in a minute, just like up above here, my graph is going to bounce or touch at 1, because technically that's an x-intercept twice. My y-intercept, I'm going to plug 0 in for x. So that's going to be 2 times -1 times -1. So that's going to be a y-intercept of 2. Okay, so we can put that in our graph over here. -2 and 1 and 2. Now, this graph, if I were to multiply it out, is going to look something like this. It's cubic, and it's a positive cubic, so I have a general idea of what's going to happen here. Okay. Now, I'm going to put it in my calculator to see a little bit more of what's going on. Okay, so we'll go to y equals here, and we will type in x plus 2, x minus 1, x minus 1. Now, if you see this actually for real, they're probably going to have this as x minus 1 squared, but it's perfectly fine to put it out there twice like that. Okay, I'm not sure what my window was last time, so I'm just going to go to Zoom Standard to put everything back to normal. And remember what I said should have happened there. The graph goes up, down, and then back up, which was that general shape that I said should happen. And the graph bounces like I thought it should. Okay, so I need to have my increasing and decreasing intervals. I'm going to base that, though, off my local maximum and local minimum. And then we'll just take a guess at what we think the inflection points are there. See if I could move this a little bit here. Let's see. There we go. Okay, so finding my minimums and my maximums. We're going to go to calculate, and let's find our maximum first. So number 4, we're going to go to the left-hand side of where we think our maximum is and hit enter. Then we'll go to the right-hand side and hit enter. And see how we've got those arrows that point towards each other. You may not have the dotted lines. The one on the right's a little bit hard to see. It's right next to the y-axis. But the idea is that I have these arrows pointing towards each other. Here's where I think my maximum is. Hit enter. Now, it turns out that my maximum is actually -1,4. How do I know that? Well, here in a minute when I go to look at my table, I'll see that -1,4 is on there. But this is kind of a common mistake, that you'll end up with a number that looks like it's practically a number, and it's not. Now, another way you can check this here real quick is if you go to calculate value, I can type in -1, and it tells me that the answer is 4. So it's not -1.0000, whatever that was. That is my maximum. Okay, so my local maximum is -1,4. Now, my minimum, I feel pretty safe, is where it's bouncing on the axis there at 1, but let's double check it. So we're going to go to calculate again and minimum, and we're going to come over here. Oops. Okay, so hit enter on one side. Again, we're on the y-axis there. Hit enter on the other. It doesn't really matter how far you go. and then where do you think it is? And you may not be able to get on it really exact, so as close as you can get. Okay, now, this is another one of those situations, and I'm kind of glad we saw both of them here, that my minimum is probably 1, 0. On the right-hand side there, that 1.77 e to the negative 12, that's an extremely small number. Again, how do I know for sure? Let's try it. Let's plug in 1 and see if it gives me 0. Because 0 would be smaller than 1.77 e to the 12. So we go to calculate, and we go to 0, and we type, oh, no, sorry, calculate value, and I'm going to type in 1, not 11. Yeah, and 1, 0. So that's my actual minimum. Now, I'm going to just jot this down here for a minute, and I'll put it in the right spot here in a minute. My minimum, we said, was 0, 1. All right, and then, I'm sorry, 1, 0, not 0, 1. Okay, I want to go ahead and do inflection point while we're on here, too. So my inflection point, I'm just estimating this, so just hit trace, and go about where you think you're about halfway in between the minimum and the maximum, the best that you can do. I think I'm going to go with this one. So my inflection point is approximately, actually, you know what? I think I just estimated this to be 0, 2. Let me go down here a little bit. Yeah, it's going to be an estimate anyway, so we're just going to go with 0, 2, because 0, 2 actually happens to be a point on my graph, and I'll show you that here in just 1 second. Okay, so increasing and decreasing intervals here. Well, we need the graph before we can do that, so let's go back here to the graph. Okay, so I'm going to go to my table, and I need some negatives here. I'm looking for numbers that'll fit on my graph. So, yeah, we're done because these numbers are getting too big. So I'm going to make a table. I'm going to make a table of values here. And in my table, I'm going to put -3, -16. Even though that doesn't fit, I'm going to still put it on there. -2, 0, -1, 4, 0, 2, 1, 0, 2, 4. And then we can put 320 in there if we want to. Okay, now start plotting some of these points here. -3, -16. I'm not actually going to put that anywhere, but I'm just going to kind of jot down that it's way down there. -2, 0, -1, 4, 0, 2, 1, 0, 2, 4, and then 320 is way up in the air. Okay, so here's what my graph's doing. It's starting at the bottom. It's going up and turning, and then going way up again. Now, I don't need to have that much of a tail on my graphs. If you wanted some of those other points, you'd have to plug in decimals because it jumps from -2 is 0 all the way to -3 is -16. But I could plug numbers like a -2.5 or something like that in if I wanted to. But we're good, okay? Now, we can get the rest of our information here that we need. The increasing interval, the graph, as I go from left to right, is going up until it gets to my maximum. So from -infinity to -1, the graph is going up. Now remember, these are intervals of x's. So from way over here, okay, my graph is going, and actually I shouldn't do it like that, from way over here, which would be -infinity. The graph is going up, 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 up until it gets to right here. Sorry, my panel's acting up on me. Hold on just a second. Okay, so until I get to right here, the graph is going up the entire time. So on the x-axis, or x intervals, which is what you do, that's from -infinity to -1. Then the graph goes down from an x value of -1 until I get to an x value of 1. Okay, that's here in the middle. Okay, that whole area is where the graph is going down. Okay, then the graph goes up again, and it goes up from 1 until +infinity. And there we go. Okay, next. This one is another cubic. So this one, again, we can have a general idea of what it looks like. There's a negative in the front. So this graph's going to look something like this. It's got that whole cubic thing going on, but the graph's going to end going down. Now this one, the only thing I can get from it from looking right now are my y-intercepts. So in this case, I'm going to plug 0 in for x. And it's not even really necessary that you do this because you can look at it and see the y-intercept's going to be -3. Now, if I graph this one now, type this in. So we have -2x to the third. Make sure you arrow out of that. I oftentimes forget to do that. It's kind of a pain to have to go back and retype it. Double check that you typed everything in there correctly, okay, and then hit graph. Okay, so there's that shape that I knew it should do. Now this one unfortunately does not have nice numbers for my zeros at least. So we're going to have to estimate where those are. Same thing with our minimums and maximums. So I'm going to just give you the minimum and maximum. I don't think we need to go through that process again, but I do want to show you how to find zeros because we haven't done that. So calculate 0. Okay, a 0 is the same thing as an x-intercept, is the same thing as a solution. So where do you think the 0 is? I think it's about right there. So go to the left of that on a number line. So hit enter. All right, go to the right-hand side of that on a number line. Hit enter. And it doesn't matter how far apart they are. Where do you think it is? So go back here, hit enter. Okay, and that's my 0. It's a yucky number, but that's it. So well, let's just do 3 sig figs. So x equals -0.336. Okay, so that's one of them. You find the other one the same way. Calculate 0. Okay, so we're going to continue over here. Hit enter on this side. Hit enter on this side. I think it's about right here. 1.68, again, if we do 3 sig figs. Now, we have one more. I'm just going to tell you the other one. The other one, and I'm going to write it underneath, is 2.66. Okay. Now, my minimum and maximum, again, I'm just going to tell you what those are so you don't have to wait for me to find them. But we do the same process that we did on the front. So there's my maximum, and the minimum, I'm just going to write it right above here, is 0.451, -4.2, it's 26. Okay. The inflection point, I'm going to hang on just a minute because once I graph this, maybe I might decide to use one of the points that I see there on the graph. So we'll come and fill that one in a minute. All right, so now to get my points on here, they're going to be yucky. Okay, I'm looking for numbers that are going to fit on my graph, and there really aren't very many. So I'm going to make a table over here again. So I've got -1, 0, 1, 2, 3, and 4. Okay, and then we're going to plot some points here. So first of all, if we approximate our zeros and put those on here, okay, so we've got negative practically 0. 1.68, so that's almost 2. And then 2.66, so that's kind of in the half here. I'm going to move this one over just a little bit. Okay, my maximum, is it about 1.23, so we'll say that's about right there. I have a minimum at about a half, and down negative 1, 2, 3, 4, maybe about right there. All right, so I've got negative 1, 13. I'm just going to kind of fudge that one and say it's up there at the very top. 0, negative 3. 1, 2, 3. 1, negative 3. 2, 1. Okay. 3, negative 3. 1, 2, 3. 1, 2, 3. And then 4, negative 27 would be way down there. Okay. So again, think about this general idea of what's happening here. The graph is starting way up here, coming down, back up, and then way down. Okay. So the graph is starting off by going down. So we're going down from negative infinity until I get to that minimum, so about 0.451. Okay, again, it's the x values. Then we go up. We're going up from that same x value until we get to the maximum, which was 2.22. And then we're going down again from 2.22 until we get to infinity. Again, those are your x intervals, okay? Now, inflection point, I don't have a point really that's there in the middle that I plotted. So let's see what we can get off the graph, the calculator. Okay, so go back to your graph and hit trace. And we're going to come here in between our minimums and maximums. I think that looks pretty good. So my inflection point is 1.36, negative 1.38. And there we are. Now, switching it up here for my quartic function. All right, so this one has 4 factors. Now, one of my factors is going to be a 0, or my zeros is going to be a 0. But we get those factors by, again, setting everything equal to 0. So I'm going to set that equal to 0. I'm going to set that equal to 0, that, and that. When I set negative x equal to 0, I get 0. I get 1, I get negative 2, I get negative 3. Okay. My y-intercept, the y-intercept, I'm going to plug 0 in. Well, that just turns out to be 0. The rest of this I'm going to have to get on looking at the graph. So let's get this in the calculator here. So that's going to be negative x, x minus 1, x plus 2, x plus 3. Okay, and I'm double checking that it's all typed in correctly. Okay, and then I hit graph. Remember, this is the one that makes the W shape, or in this case an M shape, because the graph is negative. So I know that both ends should go down because it's a negative graph. And if I multiply this out, this is to the 4th power. Okay. So, all right, so let's find our, well, again, let me just tell you the minimums and maximums and the zeros, just because that does take so long to find, and hopefully by now you feel pretty good about this. So your local maximum, I actually have 2 of them. That's going to be negative 2.58, 2.25, and 0.581, 2.25. Okay, my local minimum actually happens to be a nice number. That is at negative 1, negative 4. My approximate inflection points, I have 2 of them. So negative 1.82-ish. And there's the other one I came up with. And so now let's look for some points so we can do the rest of this here. Okay, so looking at my table, okay, looking for numbers that are going to work here. I don't have a lot to choose from, kind of even worse than the other ones I've had. So -4, -40, which again is way too big, but it lets me have a general idea if my graph is doing the right thing. Okay. All right, so let me plot these, and then I'll go back and plot my other important points. So 1, 2, 3, -4, 40 is going to be way, -40 is going to be way down there. 1, 2, -3, 0, -2, 0, -1, 1, 2, 3, 4. Got 0, 0, 1, 0, and then 2 way down here. Okay, now I already have my intercepts, but now I need my maximums. Okay, so I'm going to put those on here. Let's just get rid of this graph here for a little bit. Okay, so I have a maximum at about -2.5, a little bit more than 2. And then I have one at a little bit more than 1/2, up at negative, or a little bit more than 2. So my graph is coming starting from way down here, up, down, up, back down. So we are increasing from -infinity until I get to that maximum, so -2.58. Then the graph is going down from my maximum until I get to my minimum. Then the graph is going up until I get to the next maximum. And then the graph is going down from my maximum until I get to infinity. Alrighty, one more. Okay. Now this is another quartic, positive. So this one we're going to look more in this kind of shape. Nothing that I can find here except for the y-intercept. When I plug 0 in there, I end up with a y-intercept of 6. Okay. So now we come to the calculator and we type this one in, last one. So we have x to the 4th, arrow out of that, plus 2x to the 3rd minus 4x squared. Okay, and I'm double checking, and we're good. Okay, so graph. All right, so this one has that W shape, but it's a little weird, okay? So this one only has 2 x-intercepts. Again, you know how to find those. I'm just going to tell you what they are. X equals -2.90 and -1.33. My local maximum, this one just has one maximum, and that turned out to be -0.219, 6.23. The minimums, I have 2 of those. And they're not at the same level because this one's weird. -2.28, -6.91, and actually 1.3. I do have actually one nice number there. Now inflection points, I kind of estimated those. Let me show you the graph again here. I kind of estimated those to be about there and about there. So those would give me -1.36, -0.324, and 0.455, 4.49. Okay, so now let's get some numbers to put on here. Okay, so looks like we're going to start with -3.3. -2, -6. Okay, and that should be good. So plot these. -3, 1, 2, 3. -2, 1, 2, 3, 4, 5, 6. -1, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6. 1, 2, 3. All right. Now, plotting my other things here, my x-intercept. X-intercept, I've got one at almost -3. I've got one at -1 1/3. And I've got a maximum at almost 0, 6.23. So just kind of right barely by that other point that I already have. And then I have a minimum at a little bit more than -2, almost 7. So about right there. Actually, right, more like about right there. I forgot we weren't quite at 7. And then, oh, hold on, sorry. Need to count that again, because that was -6. 1, 2, 3, 4, 5, 6. Yeah, sorry. Almost -7, about right there. Okay, and then 1, 3. I've already got that point. Okay, so the graph again is doing this. So it's going to start up here and it's going to come down to that minimum and it's going to come up to this maximum and then it's going to come here. And I don't have any points past 1 because they were too big, but it's going to end up going back up like this. So this graph starts off by going down. You're looking at it from left to right. So we're going to go from -infinity until we get to that minimum, which was -2.28. Then the graph goes up from that minimum until we get to the maximum, -0.219. Then the graph goes down again from -0.219 until we get to our other minimum, which is 1. Oh, sorry. Till we get to 1. Then we go up from 1 till we get to infinity. So use what you know about the graph to have an idea that you did graph it correctly. You do have a few graphs that may go off the grid. So if you know that you should be having another maximum, or hey, I should be having another x-intercept, or hey, this graph has both ends going up, but it's not an even graph. So it must come back down somewhere. Then that means you need to make your window bigger. Again, if you're having troubles with the graphing calculator, be sure to let me know.